people, let us look at this given statement here. We are given a 7 meter long beam, right, supported by two supports. Each support it is 1 meter from an end. This is the support. 1 meter from an end. From an end, you measure 1 meter, you put your support. This is what we have. From the end, you measure 1 meter, you put your support. That's what we have there. The beam carries the following loads: a concentrated or point load of 30 kilonewton at the right end. This is what we have: 30 kilonewton at the right end. A concentrated load of 30 kilonewton 2 meters from the right end. Now you will measure your 2 meter from the right end. You measure what 2 meters. Then you put your 30 kilonewton or a concentrated load there, right? A concentrated load of 30 kilonewton at the left end. This is what we have at the left end. There we are told that they've put what, a 30 kilonewton force there. Then there's a uniformly distributed load of 5 kilonewton per meter across the first 5 meters from the left, right? Now our beam is 7 meters. From the right end we are having 1, then we are having 2. That which will be left, it is 5. That means from the left end to this point here, we are having what? We are having a UDL, right? We are having a UDL. Now, the first question is that draw the shear force and bending moment diagram and show the principal or main values on the diagram. Now, before we can draw the shear force and the bending moment, we therefore have to calculate the reactional supports. After calculating the reactional support, we then have to calculate the bending moment. In calculating the reactional support, we want to say take moment at RA. Now, taking moment at RA, we will therefore determine which forces are rotating clockwise and which forces are rotating what? Anti-clockwise. Anti-clockwise. But you need to state where you have taken moment. If you have taken moment at A, you need to indicate that. Take moment at A, at RA. You need to indicate so as to know where our clockwise and anti-clockwise, which forces are rotating clockwise and anti-clockwise. If this is where you have taken moment, you can tell this force is rotating anti-clockwise. RB is rotating what? Anti-clockwise. Then this one, the 30, it's rotating clockwise, and this one is rotating clockwise. Now, before we can then calculate our reactional support, we therefore have to convert the UDL into a concentrated load. Now, in converting the UDL to be a concentrated load, we are given the UDL, it is 5 kilonewton per meter. When you convert it, you need to multiply by that displacement. Now, from this point to where the reactional support is, the displacement it is 1. Now, we therefore have to multiply this UDL value. Our UDL, it is given as 5. We are given the UDL as 5 kilonewton per meter. Right. In converting it to be a concentrated load, we are going to say 5 kilonewton per meter multiplied by 1 meter. The bases are the same of these meters. Then we will add the exponent. -1 plus 1 equals to 0. Any number to the power 0 equals to 1. Then the force there would be what? 5 kilonewton. That means here we are having a force of what? Of 5 kilonewton. Now, after converting the UDL, you must put it at the center of this displacement. And how do we get the center of the displacement? You have to say 1 divided by 2 for you to get what? The center. Then it will give you what? 0.5. Then you put that force in that center. Boom. We have 5 here. Then the center it is 0.5. Right. It means from here to there 0.5, from here to there 0.5. Then we have to convert as well from this point to the point of 30, converting what? The UDL to be a concentrated load. We will do the same procedure. You will say 5 multiplied by 4, then it gives you what? 20. Then it will give you 20. Then the center of it, obviously, 4 divided by 2, you get what? 2. Right. Then you put it at the center. Then the center, it is 2. Right. The center, it is 2 of that distance. Then you can take moment at RA in calculating what? The reactional support, RB. Now, we've now added 2 forces. We therefore have to determine as well their direction, if they are rotating clockwise or anti-clockwise. This force, it's rotating what? Anti-clockwise. This one is rotating what? Clockwise. Now we are having 20 forces which are rotating clockwise. It is 20 multiplied by the distance from here to RA, it is 2. Plus another force which is rotating clockwise, it is this one, 30. Now it will be 30 multiplied by the distance from force of 30 to where we have taken moment at RA. The distance there it is 4 meters. Multiplied by 4 plus another 30. Which 30 is that one? It is this one. It will be 30 multiplied by distance from the point of 30 to where we have taken moment. The distance there it is 6. Now it will be 30 multiplied by 6 equals to the anti-clockwise forces. I'm having RB, it's rotating anti-clockwise. Then I'm having 5 rotating anti and 20 anti. Now we'll start with this 20. We are having 20 multiplied by 1 plus 5 multiplied by the distance from where 5 is to RA, it is what? 0.5 multiplied by 0.5 right plus RB multiplied by the distance from where RB is to where RA is, it is what? It is 5. Now multiply by 5. Right. And we get our answers as 40 plus 30 I'm having RB equals to 340 the 340 it is all this side, 20 multiplied by 2 plus 30 multiplied by 4 plus 30 multiplied by 6. Then it will be minus. Then we'll have to transpose this 2. It is 20 plus 20 multiplied by 1, it is 20 plus 5 multiplied by, it will give us 22, comma 5 divide by 5. answer will be our answer is 63. What my answer is 63.5 kilonewtons. Now I managed to calculate the RP. It is 63.5. Then you therefore need to repeat the process again, but now you'll be taking moment at RA. Now take moment at RA. When you take moment at RA, you are calculating, when taking moment at RB, when taking moment at RB, you are determining for RA. At RB, when we have taken moment at RB, we are determining what RA. We therefore have to determine from RB which forces are rotating clockwise and which forces are rotating anti-clockwise. Right. If this is where we have taken moment, we are able to determine the rotation of this force. This force is rotating clockwise, RA is rotating clockwise. Then the anti-clockwise that we have, it is this 30, 25, and that one, and the 20. Let's start with the clockwise forces. I'm having 30 multiplied by 1. Having 30 multiplied by 1 plus another one, it is RA multiplied by the distance from where RA is to where RB is, it is 5. You can tell from here to there, it is what? It is 5. Now, we got 5 as well when we took moment at RA. We got 5 and we are getting 5 as well in calculating RA. That gives me confidence that my beam, it is what? It is balanced. Now let's look at the anti-clockwise forces. It is 30 multiplied by 1. I'm having 30 multiplied by 1 plus 20, force 20 multiplied by the distance from here to there, it is what? From here to there, it is 2. That means it would be what? 3 multiplied by 3 plus 5 multiplied by 5.5. The distance from where 5 is to where RB is, I'm having 1 plus 4 plus this smaller distance 0.5, then I'm having what? 5.5. It will be 5 multiplied by 5.5 plus 20. The distance from where 20 is to where RB is, it is 1 plus 4, it is 5 plus 1, it is 6. It will be multiplied by 6. Then we can go ahead and calculate for RA. Right. Then I get my answer as, in calculating for the right hand side, I got my answer as 183.5. It will be minus 30 divided by 5. Which 30 is that one? It is this one. When you are transposing on the other side, the sign will change to be what? To be negative. Now let's see. Minus 30 divide by 5. No, what did I do? Did I add everything? Let's see. Forces which are rotating clockwise, it is this one. 30 multiplied by 1. And this one. The anti-clockwise, it is 30 multiplied by 1. Then it is 20 multiplied by 3. Then it is 5 multiplied by 5.5. Then it is 6 multiplied by. I think I've made a mistake somewhere. Let's recalculate. I'm having 30 multiplied by 1 plus 20 multiplied by 3 plus 5 multiplied by 5.5 plus 20 multiplied by 6. Yes, I get my answer as 237, not the one that I got there. It is 237. It is 2, 3, 7, comma 5. Right. Minus 30 divide by 5. Then I get my answer as 41, comma 5. 41,5 kilonewton. We therefore managed to calculate our RA. Our RA, it is 41, comma 5. Then we can therefore go ahead and calculate. We can go ahead and test if our beam balances, if our forces they balance. In calculating that, we will be using same the principles of equilibrium or moment of the law of moment. Saying sum of the upward forces equals to sum of the downward forces. Right. Upward forces equals to sum of the downward forces. That's what we'll be using to calculate that which they want us to calculate. Now we are having upward forces. It is 41, comma 5 plus 63, comma 5 equals to downward forces. I'm having 20 plus 5 plus 20 plus 30 plus 30. Now let's add them and see if they balances. On the left hand side, I get my answer as 105. Then on the right hand side, it is 20 plus 5 plus 20 plus 30 plus 30. I as well get 105. That simply says to me, my beam, it is balanced. My beam, it is at the state of equilibrium, the state of 0. This is how you calculate your reactional support on your beam. Thank you, good people. Then we'll continue in drawing the shear force and in calculating the bending